Welcome to 3 Minutes With, where we meet researchers and their precision agriculture projects. Today we have Andre Colaco from CSIRO to continue the Future Farm series.
Thanks, Nicole. Hi, everyone. I'm here to talk to you about Future Farm, and more specifically about our field program and the scientific approaches we're following for the development of digitally based decision support systems for nitrogen in cereal crops. So Future Farm established a network of on-farm trials since 2018 in collaboration with farmers. And as you can see, our trials are spread across Australia with the CSIRO team looking after the Western and the South Australian trials. And we have also partners with our Agriculture Victoria and University of Sydney looking after the eastern sites. I'm more particularly involved in the South Australian trials. Our trials are based on large-scale, spatially distributed experimental designs, which are implemented and monitored using precision agriculture tools, such as controlled traffic, variable rate equipment, and yield monitoring, for example. And this map here illustrates one of our trials where we have a nitrogen-rich strip and nitrogen-minus plots spread across the paddock to create a range of nitrogen availability for the crop. And as you can see, these strips are crossing the different soil zones in the paddock, which were previously mapped based on digital soil surveys. We monitored these trials throughout the season using remote and proximal crop sensing. We also have soil moisture sensors spread across the paddock. And we're collecting plant and soil samples at these target sampling locations for sensor calibration. So we can build this spatial database with the different information layers across the paddock. So the overall idea is that these trials are designed to explore the natural variability found in the field, so we can make observations of crop response to nitrogen and collect information across a range of crop and soil conditions within each trial. So the different research groups in Future Farm are exploring a range of approaches for a sensor-based nitrogen decision. And at the moment, I'm particularly involved in 3 approaches. So the first one, we're aiming to obtain a response function based on the sensor value and the response and the on-farm experimentation. And as you can see here in this example, the mid-season NDVI response was quite similar with the final crop response in terms of nitrogen, and they're both indicating a similar optimum nitrogen level. So we're now exploring the use of soil moisture information to increase the reliability of this approach across different low rainfall, rainfall environments. And the second approach is looking at nitrogen dilution and how the critical nitrogen level varies depending on crop biomass. So we're looking into different sensors to predict both crop biomass and nitrogen concentration. And we're looking into LiDAR and reflectance sensors for the prediction of those crop features. So we can use this framework here for a nitrogen decision. And finally, we're developing also non-mechanistic sensor-based algorithms that put together a range of information from a range of sources, including sensors and off-farm data as well, and on-farm experimentation. So we put all this together and calibrate it directly against an optimal nitrogen decision. So I'm more particularly involved in the on-farm data, such as the sensing data and the on-farm experimentation, and other colleagues are looking into the off-farm data, such as weather data and remote sensing information at the regional level as well. So we believe that by exploring a range of options and approaches, we'll be better positioned to deliver value to farmers that might have different data availability and different risk profiles in different farm operation and production systems as well. So watch this space to find more about our results, and thank you for watching.